Yeah, good morning. We're going to get started quickly, shortly. Could somebody maybe close the doors? Thank you very much. Okay, good morning. Thanks for coming to Icnrg. We are Dave Wren, Börje Ullmann, and I'm Dirk Kutscher. This is Icnrg in Bangkok. As usual, let's consider the IETF IPR policy. So just very briefly, it's quite similar to the IETF IPR policy. If you see anything or present anything that is related to IPR, you're expected to let the group know in a short time frame. Yeah, we have a mailing list. We have a wiki. The wiki is the place where we typically store all the, say, current meeting information. This meeting, so we are super grateful that we already have a note taker. Thanks again, Marie-José. Not sure if you want to use the Etherpad, but if you do there, you find the link on the slides or on the IETF agenda.
And also, if any would like to contribute to the minutes, you're free to write in the Etherpad directly if you want to add something particular.
Yeah, all the material is online already, so if somebody follows this remotely, he would get all the material there. This is our agenda for today. So we have 2 hours. So we start with 2 use case presentations. So Simon is going to talk about ICN architectures in smart buildings, and then we have Kanchana, who will present air quality monitoring use case. This is followed by a blog on ICN management tools, CCN Info, and so compared to that ping and trace route, we have a brief update on MapMe. Ravi is going to do an update on the ICN IoT draft, and Thomas will present an update on the ICN low-pen work. Any need to bash this agenda? Any comments? Great. To those of you who haven't been following every meeting recently, so we had, since Montreal, so last IETF, we had 2 interims. One after the ACM ICN conference in Boston in September, and one just last Sunday here in Bangkok. So I'm not going to give you the total detailed summary of all the presentations there, so everything is online. I'm going to talk about in the next slides a little bit about work items that popped up, and so like relevant things that happened there. Okay, so if you would have to describe what Icnrg is actually doing in terms of technology, so we thought a picture like this could be helpful. So, I mean, Icnrg is a say multi-project group that tries to do continuous work on, say, ICN technology development and experimentation. And so you could say we have something, like a core specification, so things like CCNX, semantics, and messages. We have, work that looks a bit into getting this implemented on specific link layers, for example. So like Thomas as low-pen work, for example. HICN could perhaps be seen in this category. And then we have, so in the in this, so above the core spec layer, if you want, a couple of extensions. So mobility support, things like MapMe, for example, or other work that is done outside of Icnrg, like Kite. We have work on name solutions, so a bit like infrastructure services. There are some proposed extensions, so RISE, remote method invocation would be one. And yeah, also say helping or say, yeah, extensions like flow classification, quality of service mechanisms, and so on. So some of those actually, you know, kind of extend or modify things like the core specification or the node behavior. For example, RISE and has a certain extended behavior, MapMe as well. So it's not a clear layering, but I mean, you get the idea. On the far right hand side, we have things like our management tools, so CCN Info, ping traceroute, for example. And then yeah, we're looking at applications and how they interact with the system, how they could make use of these say different facilities. So that's how we currently, so at a very high level, kind of would like to kind of describe the technical work here. Of course, there's also other work going on, things like deployment considerations, terminology, and so on. That's not on this slide. This is really more the technical work. Yeah, I hope this explains a little bit. Let us know if you have comments or whether we are missing something which is quite possible. Quick update on our work items. So, you know, we have these two specifications, so CCN messages and semantics. So basically, they passed all the polls here in the group and also in the ISG. Unfortunately, we are currently waiting for the IETF chair to move this to the next level. That would be review in the ISG and then finally ship this to the IRC editor. So we're trying to progress this. It's a bit slow right now, the progress there. We had the FLIC, so this manifest specification, so how you could describe ICN object that form a larger file, for example. So this draft, unfortunately, is currently expired. So we're talking to the authors, but I mean, everyone is quite time constrained, so Chris has another focus now. On the other hand, we think this is really, really important work and really useful, and would really like to get this out at some point. So if anybody, you know, wants to, you know, have a long-lasting contribution impact on ICN and is interested in FLIC, maybe just talk to Chris and Christian whether maybe they could need some help. So by the way, so when I showed this other picture before, so when I mention specifications like CCNX, for example, so that doesn't mean like, for example, in an IETF working group context, this is the one solution that the group endorses. So what we are really doing here is research and experimentation. So we can easily afford several incompatible competing proposals and still publish each of those as experimental RCs, for example. So it doesn't mean that CCNX is the Icnrg specification. It's one of the things that people brought to the group. Certainly, Icnrg is open to other work as well. Okay, we recently finished in this group we thought the ICN in disaster scenarios draft. There were some comments in the IRC review, and so we really would like the authors to consider these comments and come up with an update. So that also hopefully should happen in the next weeks. We have the deployment consideration draft that is basically, yeah, finished last call here in the group. We are also currently waiting for the IETF chair to initiate the review in the ISG. We recently adopted CCN Info. So Toshi-san is going to talk about this in a bit, so I don't need to say much. We also adopted the ICN application to low-pan networks, with what Thomas is going to talk about later. Let's get to this a bit later. We also adopted 2 drafts on name resolution. So one is called the name resolution, the requirements draft for name resolution, discussing more the motivation and requirements. That was presented on Sunday. And the other one is called architectural considerations of ICN using NRS. So a bit more the, say, broader picture and architectural impact. Right, please fill out the blue sheets. Interestingly, at the last, so not this Sunday, but the Boston interim, we had invited people from Mobility First to give us a first, say, overview about the global name service, GNS, that they developed in Mobility First. And so we think that could actually be a fruitful discussion. So there's a solid body of work in that project. So the people we talked to are actually interested to see how that could perhaps help ICN, or at least help our discussion here. We have the terminology draft. Bastian kindly updated this recently with editorial updates mostly. We just discussed it in a little bit. So Bastian is going to come back to you on the mailing list to ask for additional comments. We think it's relatively complete, and it could be one of the candidates that we, for the next draft, we want to finish up here and then publish eventually. We had the native deployment of ICN in LTE networks draft. So that was also presented on Sunday, and there is an email on the mailing list that is discussing next steps. So I just point you to that right now. And Ravi later is going to talk about the ICN IoT draft, so how IoT can leverage ICN features. NetMe, so the mobility, the anchorless mobility support was updated. What happened is that Cisco declared their IPR. So recently on their it's the usual Cisco policy. So Dave is going to do the update for the authors who couldn't make it this week. Ping traceroute as well. We'll talk about this later. So this is the rather simple or basic path discovery and testing facility. We have a couple of things related to QoS. So one is the flow classification draft. So how to encode equivalence classes in ICN, and what consumers, producers, and forwarders should do with it. Could be a basis for QoS. We had Greg's and colleagues, co-authors draft on IP tunneling over CCN. So we're actually interesting proposal to do ICN or provide a multiplane to IP without using the existing or legacy tunneling mechanisms. That is something where we could also think about next steps. So I think last time that was presented, people felt it was useful work. Greg, are you in the room? Any suggestion from your side?
Review would be nice to draft and comments on the mailing list.
Okay, so then let's do it like this. So so let's initiate like a review on the mail list. So please, if you're interested in doing IP over CCN, have a look. We have the ICN over 5G next-gen core architecture draft hasn't been updated. And we have the dynamic interdomain mobility support framework for ICN that was also presented, I think, 1 or 2 meetings before and hasn't been updated. There is new work, so I mentioned the flow classification earlier. So there's an additional draft on QoS. So that draft currently is describing how to basically use a diff-serve-like model. However, there's a thread on the mailing list discussing slightly other options, and we had a really interesting discussion on Sunday. Maybe please check the presentation on that one.
And the minutes.
And the minutes, yeah. There is a new draft on remote method invocation that we presented on Sunday that's intended as a general basis for NFN-like interactions in ICN. And we also have a new draft on AR, VR, so basically one application of ICN. And then a couple of other drafts that I don't go into detail about right now. So they're also in the data tracker, haven't been recently updated. Please let us know if you want to say anything about this or know anything about this. Otherwise, let's move on and start with the first presentation, and then it's going to be Simon.
Thanks. Good morning. So I will be presenting the use case of applying ICN architecture in smart buildings. And the interesting observation here is that we've been doing that for a couple of years within Bluetooth SIG with the system known as Bluetooth Mesh. That involves both the low-power short-range radio transport technology, including like multi-hop network, and the application layer for building automation as well. And what was surprising to me, kind of maybe a year ago, is that many concepts that we developed there were kind of I wouldn't say maybe counterintuitive, but they were definitely against the conventional wisdom because everybody else was doing like node-based address routing and point-to-point unicast communication, and we came with the concept of, hey, let's optimize the network for massive multicast, and let's use pub-sub paradigm. And then we realized that the friends at Icnrg are like using the same concept for the big internet. So that was very encouraging and refreshing. So that's what initially brought me here to this group. And Bluetooth Mesh is today, it's not an IP-based system. So we are moving into that direction. So my interest here is as well to like figure out how to merge the IP-based approach and whether and how the ICN concept should be brought into that system. So the highlights here are that from the practical perspective, we were looking for simplified configuration, and named addressable data really helps there. We were looking at scalability and no points of failure in a network, and we realized that we need to use, like at the transport level, the network must support multicast as a primary method of propagating messages, and pub-sub is really the right way to go when dealing with bigger systems. And by bigger systems, I mean like building like this one, it's probably in the range of 20,000-30,000 lights, for example, and it will, like buildings like this one will soon have equal amount of sensors. They don't are there yet, but definitely, like, the trend is that each light point in a building is equipped with sensors and is a sensor itself, because it can provide maintenance data and such. So speaking about the lighting application, so the concept here, on the left side you have the traditional approach illustrated, on the right side is the ICN approach. So in a lighting system, so the square boxes are light fixtures, like office trophers, and they have little antennas representing that they communicate over a wireless network, and ABC are representing sensors. They can have multiple sensing elements in a package. And the blue box is the controller. So the traditional approach has been that sensors, ABC, are reporting some data, and that data is collected by the controller. The controller runs the control algorithms and then issues control messages that control the light fixtures. So the lights, first of all, like the basic scenario is occupancy. So you enter a room, the lights come up, you leave the room, and after a while they go dim to off. And that's how everybody has been doing that today. So the first observation that we had was that there is some necessary traffic coming from the controller to the light fixtures, because if you realize that the controller is a piece of software, then today you can distribute that across the network. So you don't need to have a single controller that controls the whole thing. You can have a copy of a controller embedded into each node. So that alone saves a huge amount of traffic on the network, and also makes the network much more redundant, because you suddenly have a completely distributed system. And the second observation was how to easily match the sources of information with the consumers of information. And of course, what is represented here by the hashtag, like the Twitter-like paradigm of pub/sub, is really applicable here, because that really decouples the controllers or controller-equipped light fixtures. They subscribe to given information, like the lights in this room are interested in occupancy in this room. So that's the information that they are interested in. So they want to subscribe to that. And if that information is addressable, then of course, the whole system is naturally easy to configure. And the sensors, they publish again, it's really not important how many sensors you have in the room. It's important that they all contribute to the whole block of information referred to as occupancy in the room we are meeting to, right? So meeting to occupancy is our addressable info block, and many sensors in the room contribute to that, publish to that address technically, and the light fixtures subscribe to it. And of course, you can have more advanced configuration as illustrated here. So Luminaire may also be interested in subscribing to ambient light level information. So that's referred to as daylight harvesting. So the luminaires closer to windows, they are dimmer, and luminaires that are further out are brighter to level the light level in the room. So in that case, you need at least two pieces of addressable information. One is the ambient light level, and the other is occupancy. Of course, you might have multiple zones, so that depends on how many light sensing elements you have. So you might have a zone that's closer to the projection screen and the sensors that are further out, and then you may want to set the thing that's close to projection screen, it is dimmer, because that makes the projection better visible. And also, as illustrated on the right side, the luminaires themselves can produce information, because they produce information about their status, their health, their operating parameters, and that's very important. And that information goes to another address that is like a system health address, and that may be subscribed to by a variety of system monitoring devices. like little boxes that display, okay, this is running okay, or the network operating center that can display the overall health of the entire system. And of course, you can mix and match. So it's really a peer-to-peer system. You don't have a clear distinction between who really is a consumer, because a consumer is also a producer. So it's a flat peer-to-peer architecture that anyone can contribute the information, and anybody can subscribe to that information. And what's interesting here is that this decoupling, by addressing the information, gives us the opportunity to really simplify the configuration, because yeah, I'll get there. I have one more slide. One configuration example that is also illustrated here, and it's color-coded. So the luminaries in the upper row, they are denoted by the orange antennas, and they subscribe to the orange light sensor. And the ones at the bottom, the green ones, they subscribe to the green light sensor, and each luminary has a occupancy sensor, and they are all in the same room. So you can imagine that all the lights, all the occupancy sensors, they publish to the same address. The orange light sensor publishes to the zone 1 address. The green light sensor publishes to zone 2, and then they subscribe accordingly. And again, this is a completely flat system with no privileged host or a controller, and it's completely distributed. So these are the principles, and Bluetooth Mesh, as I mentioned, it's been out there for some time already, and it's commercially available since July last year. There are today about close to 100 different qualified products, and they are interoperable with each other, so the installers can mix and match sensors and drivers and switches, dimmers from different manufacturers, and it all works based on that paradigm. So it kind of proves itself, because already there are case studies that showcase buildings that are equipped with exactly this system, and the benefits from the configuration simplicity and reliability are really huge. So the three highlights that I would like to illustrate here is how, for example, simplicity of configuration and maintenance is achieved. Once you have this indirect binding between producers and consumers by the layer of addressable information, operations such as exchanging a broken luminary are very easy, because you just exchange the device, and then you only need to subscribe it to the information. On the sender side, nothing needs to be changed. So it's very, from a maintenance perspective, very, very simple. And scalability comes naturally, and it's even more natural taking into account the fact that this is a wireless network. So you don't have isolation between ports that the information is going. It's always broadcast medium. So nodes are overhearing each other. So it's inherently multicast by nature. That's how radio systems are built, and by distributing the controller application to the nodes, then we are like halving the amount of traffic immediately. And then, of course, because sensing is not only for one application. Occupancy sensor can contribute to lights, it can contribute to HVAC system, it can contribute to space utilization application, it can contribute to who knows what. And that's the beauty of that the sensor just publishes, hey, there's occupancy in the room, or there's no occupancy in the room, and whoever wants may subscribe to it, and the sensor doesn't need to be reconfigured. So that ends up in a very robust, flexible, and simple to configure system. So that reliability aspect is also very important, because we really have achieved here the no single point of failure setup, because it's all distributed. So it marries the concept of ICN with the concept of distributing, which is the the trend that is really taking up today, and it really makes sense to push the computing to the very edge. So each node has its own controller logic, and it's capable of subscribing to whatever information it needs, and then it makes its own decisions. And if it fails, only one node fails, and the rest of the system keeps operating. So it's more like a swarm type of an organism. So it's a collectively intelligent system where each cell is just a contributor to the behavior of the overall system. So we are like getting all the benefits of that approach. So that's it. I'm not sure if we have time for questions or not. Yep, 2 minutes. And please.
Thomas Schmidt, HW Hamburg. Question, do you have implementations for this?
Yes.
I wonder, how do you do ICN over Bluetooth? I mean, that is a thing like the UCLA and people and we are working on. Do you do this directly on the L2 CAP layer, or how do you do this?
So Bluetooth Mesh is a new architecture or topology available from Bluetooth since 2017.
Yeah,
it doesn't use L2 CAP. It doesn't use L2 CAP. It works.
Isn't this based on BLE?
It's based on BLE radio, but it only uses the radio layer, and then everything on top is a new stack.
And where do you situate your ICN layer?
As I mentioned, there is no IP in that system, so we cannot say it's ICN as like we understand in this group. It's a concept that's very similar because it's pub/sub, it's multicast, it's just different addressing and different payloads, but
Bluetooth has never been an IP protocol, but I mean, ICN brings a networking layer here, and that is also not foreseen by Bluetooth. So you should there should be some interface on the Bluetooth where you put your ICN on top.
I think they're only doing ICN in spirit, not
yes,
in
exactly.
protocol.
Yeah.
Okay.
We do not run the protocols. I thought I made it clear, but thanks for
okay. So it's just the use of Bluetooth
the concept
in an ICN style. Okay.
Yes.
Okay.
And now what we are looking for is how to bring the two really together, because we find that architecture very applicable to the area that we are proposing Bluetooth Mesh for, like smart buildings. And now we're looking into how to inject the ICN through ICN layer in between the application and the transport network.
Dave Oren, one comment and one question. To the question first. So how do you think about how to design the namespace for these things? Because that's sort of protocol independent, but how the names get assigned and what semantics get put onto the structure of the names seems to be something everybody could learn about here, independent of whether you choose one ICN protocol architecture or another, or actually bypass it directly to the application. So I'm curious what insight you can provide around namespace design.
Addressing space for the network is short addresses, 16-bit addresses, and there is also a concept for of 128-bit addresses that can be used for the pub/sub relationships. And currently, they are just randomly generated, the addresses themselves, the long addresses, and we really, at the network layer, we don't have a namespace. It's managed by an external config utility, but it's definitely something we are looking into, like how to solve that.
Right. So the next one is a comment and may have more to do with the actual product design here than with the architecture. I was involved in the design of a system a few years ago that was deployed at the MIT Media Lab, which had this nice property that you could tell the difference with whether the bulb was burned out or the device was offline. And there were sensors on each of the fixtures that were actually monitoring the other fixtures. So the light sensors weren't actually separate. There were light sensors on each fixture that could figure out where all their neighbors were and whether they were working. Have you thought about anything like that?
Yeah, so this, too fast. This product here in the lower left corner, it's a sensor that you can buy today. It's in distribution, and it's actually a combined sensor and fixture controller. So the output of that device is the light level. So you can hook it directly to the power supply of the light. And it monitors, it has an ambient light sensing element, it has the occupancy sensing element, it has temperature sensing element, and yeah, it exactly is capable of doing that.
So we have to cut the line after a second. Mitchell in, but...
Ravi from Huawei. So you mentioned it's like 20, 30,000 bulbs, and you have a lot of publishers and subscribers, but I don't see, I'm not, you didn't talk about how these multicasting routing itself is managed. It's broadcast. I can understand broadcast happening in this single room. So does it mean that you basically manage the system by just localizing the network, and this network doesn't deal with anything to do with the other network in another room? Is that how it works?
Yeah, so it supports the concept of subnets, and subnets very nicely confine the traffic because traffic does not propagate across subnets. You can configure subnet bridges so it hops from one subnet to another, and the flooding is controlled with TTL and message caches on each device, so it's confined. Okay. So, for example, ambient light sensor in this room, it's unlikely that somebody in the other tower is interested in that information. There may be a gateway, but the scaling factor for gateways currently we see as around 200, 300 messages per second. So if like ambient light sensors are very talkative, so to speak. They fire every couple of times per second. So if you have a number of them in the room, then your airspace fills up quite quickly. So that's definitely coming into a hybrid physical structure, that you have gateways that offload to a faster backbone, and the last two hops maybe are wireless.
So you only have routing between the bridges, but
yes,
subnet is broadcast.
Yes.
Wes Hardiker, ISI, and I actually specifically wanted to talk about the naming problem because I've been thinking a lot about that. The way we need to address names in the communication world is often very different than how we address names contextually as humans. And it's a really hard problem, and things like, you know, when we have 50,000 lights in a building, that gets much harder because humans like to think about things of, oh, please turn the lights off. That works in my house. I can tell my local listening device, turn the lights off, and it does. And if I tell my phone here, turn the lights off, it might turn the lights off in my house. That's not what I meant. If I want to send something to John's phone, John is very contextually dependent. It's probably the person closest to me, but if he's on a different carrier or a different network, we don't have the ability to do that today. And that particular really hard problem, you know, really needs to be addressed for situations like this. And so there's a lot of work to be done in that area.
That's true. Okay, thank you very much. So Simon, quick question. Is there anything that you would like to get from Icnrg that would help your work?
Well, yeah, I think because now we are working on the design of this IP layer, because as I said, we have the networking layer and the application layer bound together. We want to inject IP in between, so the application, like the lighting control, can run over IP, as well as IP can run on top of the mesh under Bluetooth. Now, of course, there's pretty straightforward to do using the classic IP6 approach. Now, what we are looking into are how do we take advantage of the ICN concept, because we consider it very relevant, and that's still a design work, so we are kind of more listening to what this group is doing, and that's, yeah, looking for input at this moment. When we are ready with the IP design, I think that I will be able to share that with the group, and then maybe collectively we can come up with the unified architecture, because that's definitely what we are after.
Okay, yeah, sounds very good.
Thank you.
Thanks a lot. Okay, moving on. So we are extremely glad that we have Kanchana here today. So Kanchana actually previously pioneered the introduction of the internet to Thailand, and she's now considering to do the same for ICN. Just this one for...
Okay, thank you. Right, thank you very much. And this talk was totally unplanned. We met in the lobby, and I was asked what am I working on. So this is what I'm working on: air quality monitoring in Thailand. The problem of air quality is very serious, particularly in the north of Thailand, because a lot of crop burning, and as you can see that WHO has put very serious warning to us that 3.3 million deaths linked to outdoor air pollution. And you know, the reason why I get problem with my respiratory system is because of this. And so this is the picture of the northern Thailand during the burning season, which is around March, April. You can see that with the WHO, the safety PM level was only 25 microgram. But what we observed in Thailand was over 100 in the north. So it's very serious, and problem with mainly caused by hotspot. You know, the people burning their crops. So what happened today is that our pollution control department have their own very big sensors placed around the country, but it is not sufficient, because it costs around $300,000 US. So the whole country had, less than 20 stations that measure this kind of information. At the moment, there are a lot of people who get interested in this area, and a lot of them are using I don't know what the sensor, and they upload data, but the government say this data is not reliable. Now another observation that the government does is to use the satellite images to detect the burning in these areas, and they also issue ban period where any burning is illegal during the 2 months period. So we propose to use the sensors to do ground level monitoring of the PM 2.5, which is the thing that causes your lung to, creating a lot of health problems. So with this one, we try to make sure that we can provide timely warning to the local communities that get affected by PM 2.5, so that people can stay indoor, not going out to the to inhale the PM 2.5. So in my mind, I was thinking about, in the end, since I met Licia in 2011, when I listened to her talk at a conference, and I think, this is something I've been waiting for. I wanted to use the network more than just sending information. I wanted to be able to compute and using the network just like, very big distributed computers. So the idea of using NDN started since 2011, but I didn't know what kind of application I can try this NDN on. So with this particular problem, I found that it fits very well with NDN because we are dealing with a very remote area where the network is very often disconnected. So you cannot rely on a centralized system to do any data analytic and feedback, to provide the feedback to the community. You really have to have your own decentralized system, and you should, since you have decentralized system in a village, nobody is willing to pay for for electricity to run a centralized system, even in the village themselves. So if we can distribute computation to every node, then the load is distributed to everyone. And I think the NDN concept fits very well with that. So another thing is that we have multiple data sources where each node produce stream of readings and all the time. So if we can leave that node to do that job, we can also always take the stream and do some computation locally. So this is what, in order to do this kind of project, you need to convince people in the, the domain expert in environmental engineering or environmental people to listen to you. Otherwise, they don't think what you are doing is serious, and you need to get their help in order to set up more stations. So I spent time to work with them, and we started by putting our sensors in villages in the north of Thailand, on the Thai-Burmese border, where what happened this year, that was the worst affected area. So we set up these sensors in, I can't remember how many villages, but about 10 sensors altogether. This is the PM sensor that we used, plant tower PMS 7003. I think is the one that's commonly used by PM sensors. Okay, so this is our node. We worked with our colleagues in the University of Sorbonne and I think Macau, and met several other universities. So this is our node. You may notice that we used Ubuntu Neo with 1 gig because we plan to run computation in each node, and we have SD card to store readings. Even when the network, when you don't have the network, you can keep the data and then upload it when you get connection. Our node has a Wi-Fi connection, but we are putting LoRaWAN on this node at the moment. The sensors that we have is for PM1 to 2.5 and PM10. You just tell me when.
Yeah. You're good.
Right, and then we upload the data to the cloud, and we have our website that you can have a look at. The data run all the time, 7 to 24 hours. This is the URL. Now, after we collected data from the season, we involve the data and data science people and environmental researchers to analyze our data. So they found that we should separate our data into 4 zones, and then they analyzed our data and to be, they use our data to study the movement of the PM 2.5 with respect to burning sources and with respect to the wind. And finally, they work on a prediction model where you can use the data to predict what's going to happen in any particular area, which is which could not be done in the with the existing existing warning system, because the currently when you warn the people, you give the warning for the whole province, not a particular village, and normally it's very inaccurate. So now this is what we found. You could predict the PM 2.5 quite accurately from our data. And we found that the burning, PM level relates to the burning period, relates to the number of hotspots. So we are now convinced, and we are going to move forward. So we move to step 2 now, that where I want to insert my idea of NDN to the system. So, and what we want to do, as I said, when I listened to Licia, I thought, oh, we can do computation on the network. So, and then I found you are talking about in-network computation. So we match. The air quality, is meaningful for people in the affected area. So we need, to do computation, even though the network gets disconnected, and you can warn the people in the affected area immediately. So what we need is a programmable network. What we need, the kind of question that we need to query the network is something like to search for a possible source of fire. Okay, so if you have this kind of interest, you, instead of asking for a particular stream of data, you should be able to send your query to the network. And the network can find, you can write a program that say this kind of question can be handled by searching for sites with higher and higher PM at that particular time. And then you can trace back to the source of the fire. Of course, you can take, you can also use the wind direction to guide your search. So this kind of computation should be done locally. And the next question that we can do on this kind of network is that each community, affected community, would be interested to know what will, the PM level for tomorrow or for for the for very near future, not weeks ahead. So they would send interest to find. In order to do that, the node has to do some some modeling and prediction. And in order to do that, you need to get stream of data from the neighboring nodes, and you have to get the reading from the wind sensor and then feed that to the prediction model, and then you can provide the prediction. So this is the kind of thing we think that fits into the ICN framework.
Mm-hmm.
So what we are doing now is that we continue with the project. We try to expand the sites. We are trying to scale and put our nodes in other countries because there are many colleagues that are interested in using our node. We are trying to expand to Laos, Philippines, Indonesia, and Malaysia as well. Thank you.
Thank you very much. Super interesting. So we have time for one question.
One.
One question.
Make a smart choice.
Yeah.
So thank you very much for this inspiring talk. Thomas Schmidt from HW Hamburg. Actually, the first question is a simple one. Wouldn't it be useful for you to have small energy autonomous nodes that use harvesting? Then you, of course, would need to use smaller nodes than you use in the moment.
Yeah, this node that I just showed you would be the node that it's like a gateway where you do processing. We are building smaller nodes, and which just provide a reading.
But maybe the more interesting question, do I get you right? I mean, if you say you're searching for the highest pollution value or something, that you're actually asking for a routing scheme that routes along something like the steepest descent or something, like searching maxima in a data value?
We found that if your sensor is nearer to the source of the fire, the PM level is higher.
Yes.
So we can use NDN. We send the interest for higher and higher PM. Then you can find a geolocation of that particular sensor.
Yeah, the question
it means that we want to find the source of the burning.
Yeah, I understand. Wouldn't this actually translate into routing problems so that actually your interest is guided along the
interest? You increase the level of the PM in your interest, and the solution. Once you send the interest, the node that answer to you would be the one that is closer and closer to the source.
Okay, thank you.
Thank you.
Yeah, thanks again for bringing this to us on very short notice and making yourself available. Please keep us informed about the progress. Okay, so we're now entering the second block where we want to talk about management tools. And without further ado, I'd like to hand it over to Hitoshi-san.
Okay, so hello, I'm Hitoshi Asada. So today I'd like to talk about CCN Info draft.
Does it work?
It works? Oh, sorry.
Oh, don't press that button.
Okay, so this is...
It's possible the clicker does not work with this PowerPoint emulation, so just let me know.
Okay. So we published a paper with the name of the contrast and submitted the same contrast as an individual draft, and now it revised with a new name, which is CCN Info, because the contrast is a little bit complex. Difficult to understand the real meaning. So we changed the name, and now last month it's accepted as a research group draft. So this is a initial version of CCN Info as a research group draft. So,
yeah, normally yes, but
it takes time. Okay, so what CCN Info can provide? Actually, I already mentioned, and I already talked about the benefit and advantage, what kind of information or what kind of status we can obtain using CCN Info. So it's a really powerful networking tool. And also, precisely because it's a really powerful networking tool, we need to have some function to enable some access control or policy configuration for information disclosure. So this is also included into this draft. So this is a basic behavior. CCN Info consists of two messages. One is a request message and the other is a reply message. And the request message is initiated by CCN Info user, which is a consumer usually, and forwarded toward the publisher based on the fib entry in a hop-by-hop manner. And the request message includes request block and report blocks. I detail later. And the reply message is oppository initiated by caching router or the first hop router attached publisher or publisher itself and forwarded back toward the CCN Info user along the pip entry. And this reply message include reply block and reply sub blocks. This one also detailed later. So, so this is newly defined. The message newly defined several type values. So the CCN Info message itself is compatible with CCNX 1.0 TLB format, but request message consists of a fixed header. This is a regular CCN message format one, and also request block TLB, report block TLB, and name TLB. So these two request block TLB, report block TLBs are new. And the reply message also consists of a fixed header as well as a fixed request block TLB, report block TLB, name TLB. They are same of the request message because we just use the same message and replace the type field message type. Message type field to reply message and appended the reply block or sub block TLBs. So these are the new type values we need to understand. So packet type, request, reply, top level type, hop by hop type, and CCNX message type. Yes. Well, I made the animation, but it's already finished. Okay, my animation is not really rich, so.
So what happens is your PowerPoint point is rendered in the web browser basically, so it doesn't show the animation.
Okay, so okay, so then this is not so meaningful, but anyway, so initially the consumer initiate a request message, and the request message type is specified into this field PT request actually, but now it's already, animation is already done. So it's now it says reply, but initially it's a request. And the intermediate routers insert their block, report block inside the hop headers step by step. And finally, the last hop router or publisher itself change the message type field to reply and appended the reply block and the reply sub block information. These are the information that this includes his caching condition and so on. So the various information is inserted in these reply block and reply sub blocks, and then forwarded back to the consumer. And
give it a second. These two slides take.
Okay. Now we're playing the animation step by step, and
at least thinking about it.
and then when it's finished, I don't know.
I assume CCN Info, when you deploy it, actually runs faster than this, right?
Sorry.
So not that's unusually slow.
Just to go to the next page.
Yeah, I'm trying. It worked better before. Oh my, come on.
You want to take a question?
Yeah, let's take a question. Press the button.
Hey Eve, can you hear us?
I can hear you. Can you hear me?
Very well.
Great. I was curious, even though the animation didn't work, presumably, are you sending just a single interest and then it is generating multiple responses as it wends its way through the network? Or were you sending multiple interests, each of which go somewhere different?
So this kind of multiple pass support will be explained later. So could you just ask again later?
Sure.
Okay. So because regularly means that if there is no, okay, I'll explain it. So this is a request message and newly defined several type field and several type TLV field, and I should quickly show this, right? And request proc report. So please read the draft because it's too detailed. And reply message, it's broken. The figure is also broken, so please read the draft.
Do you want to move forward or?
Yeah, please.
Okay. More?
Yeah. Okay. Wow. Sorry, it's really broken. The slide is broken. So anyway, so CCN Info provides some unique behavior, which means that it's not a regular interest.
So with this new Chromebook setup, PDF is really the best format to send us.
Yeah. So, okay. So the request and reply communication is not really same of the ordinary interest and the data communication. So the questioner, the lady asked me, so one interest may initiate multiple reply message. It happens, but regularly means as a default, okay, I explain. As a default, so as a default, so the CCN Info message works like a ordinary interested data communication. So the strategy, even though some router has a multiple upstream interface, so some specific, so which slide do you want? Is this one? No, it's the final one. Oh yes, unique behavior. Yes, this one. So okay, so I go back. So different operations from the regular interest data are required. The system because CCN Info request should not result in bit aggregation in router during the request message transmission, and the CCN Info replies must not be cached in routers because it's something like a measurement tool. And for multipass support, routers should not limit the bit entry created by CCN Info request until timeout barrier expires. This is a unique point. This means that even though you receive the one request, if you request a multiple, if you want to fully discover the potential path for getting the some specific content, then your bit entry cannot be removed. So of course there is timeout barrier. So finally, the some message may be discarded because of the timer's expiration. But there is a timer, so you can have the potential to receive a multiple replies from upstream routers. Well, I understand this is a good point to discuss. So can I go?
I don't know. Should we discuss question immediately or?
Okay, so first, please.
The question is, I mean, this seems to me like a unique opportunity for an attacker. I mean, this is a nice attack vector to flood the pit, isn't it?
Maybe.
So similar vein, but maybe in a more positive cast. Making this a separate message type means you don't necessarily have to do resource allocation the way you would for interest data exchanges, which means the fact that you're breaking flow balance allows us to rethink how we do the resource allocation for doing these operations. One thing you'd really like to know when the request message arrives, it's what's the worst case number of reply messages that might come back. Do you have something in the request message that bounds that? Because if you had that, the resource allocator could keep track of just how much bandwidth might be needed on the reverse direction to return the replies. Have you given any thought to that?
So I think there are several, not definitive, but several solutions. One, the simplest solution is something like rate limiting. So you can just, so there is some upper limit that you can stop, even though there is someone, something like a bogus reply happens, then the router just can discard everything and he doesn't need to reply back to the consumer.
Yeah, we should talk offline about the problem with a scheme like that, because if you want to do that, these messages now have to be way lower precedence for bandwidth than normal interest data exchanges, which means they won't work when you need them the most. Let's go talk about this offline.
Okay. But in general, my feeling that rate control can help something. And also if we have some something like a router verification mechanism inside this protocol, then maybe bogus traffic can be also discarded. So, but anyway, so this is a very detailed. So I want to go to the next slide. So this is really important discussion point and one of the important open issues. So maybe I will back to that kind of discussion. And I expect that this kind of discussion happens here. So I already mentioned that. So how we can enable the multiple support. The regularly as a default, so the CCN Info message exchange is behave as something like ordinary internet data communication, because CCN Info request as a default complies with the strategy, and CCN user could trace the actual forwarding path. So usually, if the strategy allows a single path, even though some router has a multiple FIB entries toward some specific content, finally the consumer received a single data because bit entry was already removed. So regularly, if we follow that kind of regular behavior, then we don't eliminate some problem. But as an option, we should have some potential to capture the all potential forwarding path information or potential caching places that someone may want to retrieve such kind of information. So as an option, we should have some capability to allow that getting the multiple reply to to consumer. Okay. And policy information. So this is also it's a little bit tough. So we can just skip today. And discussions. So there are several. So this is an initial version of the research group draft, and I know there are several open issues and discussions we need to discuss. So especially for multiple discovery, and this one is also a little bit detailed, so we can just skip. And no, go back. Go back. Yes. And the neighbor verification. So actually, as an academic paper, we already published how the neighbor can verify each other without having something like a CA, so something like a central management system. So we already published a paper, Transaction Network Science and Engineering, and I may have a chance to refer this paper for the revised draft, or if this is really useful, we also have a plan to submit as a different or another document, internet draft, and we can discuss more. And others, maybe we have a lot of discussion. So please keep in touch and let's start the discussion. And if you have some interesting comment, then I'm really happy to hear. And okay, so today I'm happy to announce our new implementation. We call CEFO, and this is a software platform enabling CCN-based communications. It's open source, written in C. So you can just access to HTTPS CEFO.net or just capture this QR code now. Then you can go to, no, it's too early.
Too early.
It's too early. So there are several interesting functions and interesting implementations, so functions to be implemented. And there is two daemon. CEFO consists of two main daemon. One is a SafeNet. This is a forwarding daemon. It's a basic daemon. And the other is CS Manager. This is a separated daemon which support enables the content store. And SafeNet itself is very lightweight, and it can just connect to CS Manager via Unix socket or TCP socket. And also, usually, I hope, the many researchers or engineers want to develop their original implementation, but they are usually, I don't know usually, but many times don't need to care the pit management or fib management itself. So, for example, if some of the researcher or engineer want to develop the caching algorithm, replacement algorithm, or some other algorithm, or transport mechanism, routing mechanisms, they can all implement as a separate plugin libraries. So plugin library is just built in the SafeNet or CS Manager D, and they can extend easily there and create their own CCN communication building blocks. And there are several operational tools, utilities are also supported, and also, of course, the SafeInfo. This is a CCN Info already implemented. So next page. So this is a very, very easy, simple demo. So we just capture the screen and CCN Info, CCN:/news science, and this is topology, consumers here and publish here, and this is routing cache. So, and we set up 10 millisecond delay for each, and then the consumer send a request and toward along the fib, and then the CCN Info request is attached, arrived at R5, then R5 reply back toward the consumer. So this is a one-way delay, you can see, and this is round trip time. And there is a cache information here, and this content is, so the size is blah, 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 and the COB, and how many interests he received, and what kind of a chunk he stored, and the expiration time, and so on. Next, please. And this is, so someone just want to trace the network condition, and he doesn't care that, for example, caching condition, and he want to know the march pass condition instead. So in that case, consumer here and the cache is there, R2 and R4, and this request message is transmitted and toward the publisher, but actually the R1 is split the request message, and once request message is sent toward R2, and once request message sent toward P2 maybe, or R4 or somewhere here, and finally R2 and R4 reply back to C. So he received two messages. Actually, he received two messages. So one is from router 2 and the other is from router 4, and each has a RTT. Next.
One more?
Yep. So this is the final slide. So CCN Info is compatible with CCNX gateway format, and it's a powerful network tool providing various information, and it's already implemented in C4. C4 itself is, of course, it's a really ongoing. There are maybe lots of bugs, I know, but we have been working for to mature the quality, and we are really sure that we need to address many open issues, but maybe step by step. And we will revise the ID. And the comments is always welcome. Thank you.
Fantastic. That was a nice surprise.
I have one question. Have you considering the scope flooding to some kind of scope, the interest that is going to?
Yes, yes. Actually, the our specification already been mentioned about something like a expanding link search, something like expanding link search. So you limit the hop count, and then your request must be stopped at that hop count.
Okay.
And or oppositely, if you already know the caching information within, let's say, the small network, which is, for example, hop count is 3, but you don't know from 3 to hop count 5, for example, then you can specify hop count 3 between 3 and 5. Then you can search the 3 and 5. How many caches are located for your content. So it's already specified, and our implementation already support this one.
Thank you.
We need a little AV support here, I think. So I just checked the license for C4. That seems to be the special NICT license, which is like permissive MIT license, like, right?
BSD second clause too. So it's a very third clause. Sorry, basically third clause.
So
it's
you can copy, modify, just keep the copyright.
It's very right.
Great. Okay, so while we're getting set up again here, so Dave is now going to talk about ping and traceroute.
So we're running a bit behind on time, so I'm going to do this at light speed. Some of you have seen this work before. It fell into kind of hibernating state, but now that the research group has gotten interested in really moving forward on management and instrumentation tools, we kind of brought it back. What happened? The screen. Okay. So our view, and Hitoshi-san and some of us have talked about this a lot, is that there isn't a one-size-fits-all instrumentation and management tool for things. CCN Info is kind of your big toolbox that can do a whole lot of things and get really rich information back from the elements in an ICN network. The ping and traceroute are much more like, at least conceptually, the equivalent IP world tools, which is they're intended to be extremely lightweight and usable by end users to at least get some sense of how things are working. So the contention is, where's the right button?
You're using the other.
No, that's okay. Is that we need some lightweight tools for troubleshooting before employing more heavy-duty tools like CCN Info. And we'll see that these have a very different kind of target and a very different kind of approach to how they're done. So the first of these is ping, and you can think IP-style ping in your brain as your mental model for this. What we want to be able to do with ICN, since it's a richer architecture in many ways than IP, is to get information back about the targets of requests in an ICN world. So the questions we'd like to ask with this is a particular ICN forwarder reachable? Is a producer application reachable? And is a cached object on the path to a particular producer reachable? And in the process of doing multiple of these, just like we can do in the IP world, you can run several of these and to get some statistics like average and dispersion on round trip times. So one of the things we note here is that if you want to talk about the forwarder, since we're in a routing by name environment for ICN, you need to give names to the things you want to route to. So in this case, we're not necessarily interested just in getting to application objects, but we need to talk about the forwarders, which means forwarders need names. Now, I would claim, independent of any of these particular tools, you don't have a manageable network at all unless the forwarders have names on their own. So these can either be globally routable under the name of their administrator, or use some kind of forwarding hint within an administrative domain in order to get to the forwarder. What we've seen in the IP world is that some operators don't like to externalize the names of their internal resources because for one reason or another, it may open them to outside attack or competitive analysis of how their own domain is working. But at any rate, the forwarder names need to be known in some way. The second question is an application producer reachable? So we'd like to discover the forwarder that has the local connectivity, in other words, in the same system instance with the application. And then because we support caching in ICN, we'd like to be able to cut off one of these exchanges and answer that there's a cached version of a particular object that is available on path at a particular forwarder. The other thing we'd like to be able to do, and this comes up in the CCN Info context as well, is to be able to do RTT measurements in the presence of multipath. This is a generally difficult problem. Some of us have tackled it in the context of trying to do multipath congestion control. So we basically adopt the same, since this is the same group of people who designed both, we adopt sort of the same overall approach to doing this. So we use a path ID, identifier in the data message package, and then presume that this path steering work that's been going around in the research community for the last couple of years, we can import into here and use path steering to steer ping messages over particular paths. The way you obtain these path IDs is you can do path discovery. Right? The actual packet encoding is an echo request and an echo reply. Now, the interesting thing in the CCN architecture is, remember, we have both message types and packet types. The message type for this is still an interest message, but the packet type is echo request and echo reply. And this allows us to emulate the actual forwarding behavior of interest and data messages almost exactly. A couple just minor points, which is the user can direct this directly to get further management administrative information. So the information coming back can be used as the target name for doing a CCN Info style deeper query of the network. And of course, replies need to be signed here in order to avoid any kind of reflection attacks. So in the interest of time, I'm going to skip some of this. It's all in the draft. And move quickly on to traceroute. Now, what we did with traceroute is, remember, in the IP world, traceroute is done with exactly the same packet type as ping. It's a echo request, echo reply packet. It's just the processing is different. We follow a similar architecture here, but there's some differences. So we'd like to know what the path to the forwarder is, what's the path to a producer application, and what are the paths to cached objects. So we want, instead of just getting a reply, is it there, we want to look at what the path are and do hop-by-hop RTT measurements on paths. So the differences here from an encoding standpoint is we have two new packet types, although again, it's an interest data response. And the core mechanism is what came up just a few minutes ago, that it's an expanding ring broadcast. So we use hop limit expiry in order to explore the diverging paths, as would have been done with IP traceroute, same way. And that's it, I'm done. Comments on the drafts, they've been adopted by the RG. We hope to progress them forward over the next few months and potentially get them to last call. Thank you.
You can just stay there and do let me.
Yes, okay. Now for something completely different. So there's some work that's been going on primarily at Cisco. I don't work for Cisco anymore, in case people haven't noticed. But I still collaborate with the team there on a number of things, this being one of them. So since none of them can make it here today, I've been sort of called into service to present their draft. So this is not my work, this is their work. So what does MapD do very quickly before I go into the updates is ICN needs mechanisms to support producer mobility. Consumer mobility is kind of naturally built into the CCN and NDN architectures. We don't need to talk about it much. When you do producer mobility on a mobile network, there are only a few feasible ways to do this. You can do anchored mobility with a reflection point back in the network. You can try to make your routing protocols converge so fast that you can track directly via routing the movement of a producer, or you can design some kind of custom mechanism. And MapMe is kind of a compromise custom mechanism. It assumes that your routing can converge reasonably fast, meaning in some small number of seconds. So this creates volatile state that allows you to track producers and deal with their mobility during the time that the routing is reconverging. So this draft has been around for a little while. There is Cisco IPR on it. I think that's mentioned somewhere, but I'll mention it right on the top. So I won't present the whole draft, obviously, in the interest of time, and people can read it. But there have been a few changes since the last time we went through this. The first is that the original spec had a sort of like a full-blown retransmission management scheme. So it had its own kind of transport protocol properties for the control messages that were going back and forth between the diversion elements that did the bypass routing. These have been simplified considerably. It turns out it didn't need all those mechanisms after building it and trying it out a bit. Secondly, there were some assumptions in the previous version of the draft was that what you were talking to as an output face was simply a layer 2 mobile network interface to a mobile network. This scheme obviously has much more broad applicability to that, so the descriptions have been broadened to deal with any type of face, including tunnels, IP tunnels, UDP tunnels, any kind of tunnel. So that's been expanded. Last time there was I forget whether it was in Cambridge or the previous meeting, we had a presentation on the socket interface that has been designed for HICN and potentially other ICN flavors. And it's now, this scheme is now implemented for that socket interface. So the code that you get is workable with the socket interface that that's been provided by Cisco for HICN. So where we are here is that despite the name of the document, it's been misnamed originally, and the chairs had, too busy to worry about that too much. This is not yet an RG adopted draft, even though it's named as if it were, although it's marked in the data tracker correctly. We'd like more feedback, or the authors would like more feedback from the Icnrg community. Find out whether other people are interested in taking the implementation and using it for various things, and see about, we'll talk more about adoption of this and whether it's a good idea at InProg. Thank you.
Thanks a lot, Dave, for doing this quickly. Yeah, so we think this is a nice, useful mechanism that could help with producer mobility in some scenarios. Please have a look and let us know, and let the others know what you think. All right, so we're moving on. Ravi is next. Update on the ICN IoT draft. Here you go.
Hi. So this draft has been in this group for some time. So the basic goal of this draft is, it's more an informational draft. So the idea is to basically present how ICN, it would be a good kind of a network stack for to serve several IoT applications. And so I mean, since it's been there, I hope people who are interested would have gone through it at least once. And so I'll not go into the history of the draft as such, but just focus on the changes that we have made. So primarily we have cut down on the authors list. I mean, so primarily to the set of authors who have been actively contributing to the draft, and we have included iTouch too, and who's been contributing now. So this is the primarily the table of content of the draft. I could spend some time here. So the basic idea is to, as I said, it tries to motivate ICN for IoT, and I think it kind of resonates with the kind of points that Simon brought out, saying that IoT networks primarily are information-centric. They're just producing information. So all you need from an IoT network is to get that piece of information, or if you can talk in terms of a consumer publisher or a model, it's fundamentally the same. So in this, what we try to do is to primarily in section 3 is to identify some of the general requirements of IoT from an IoT perspective. So in terms of naming, security, privacy, and so on and so forth. Then we in section 4 we basically talk about how the current architectures fail to scale, primarily because I mean IoT it's a clutter of stacks there, and so primarily this huge set of interoperability issues, all the issues are fundamentally handled at the application gateway level, and that's a basic point that this section 4 brings out. And then section 5 is where we talk about how the different constructs of ICN can be used to meet the requirements of the things that we mentioned in section 3, and the different design choices you could make within ICN to meet those requirements. Yeah, so that's about the main meat of the draft. So going into the changes that we did, I mean, mostly it is about, most of it is very editorial. I mean, there was some redundant discussion that we eliminated, and we kind of moved some of the discussion into different to make it more relevant where we felt it was lying further out in the draft. So in section 2 we have this section was kind of hidden somewhere in section, I think section 4 or something, so we pulled it up. And so then we have the services scenario. So initially that was kind of the section 2. So the main idea with services scenario, again, IoT is a very siloed kind of an area. So what we provide there is discussions with on specific scenarios, and then see how ICN could help those specific scenarios. So then there was some discussion on naming, where we had some discussion on, particularly this was the requirements kind of the part of the draft. So we had some specific solutions being discussed, so we eliminated that. Contextual communication in terms of long-term, short-term context, and so there's some kind of so we tried to merge, kind of make the discussion more kind of seamless to read, and then some renaming of this section. So primarily this is the main changes that we made to the draft, and since we did not do it in the last IETF, we wanted to bring this back so that people can have again a good review of it and provide us more feedback. So we had some feedback from Thomas on some references, and we should, I didn't iterate because I thought we could get in more inputs before coming up with a new version. So more comments and are requested for this. Thanks.
Yeah, thanks a lot, Ravi. I mean, if people have more ideas, please talk to Ravi offline. Okay, thanks. So Thomas is next. Update on the LoPan specification. There you go.
This should work. Yeah. Okay. So this is just a brief update on the LoPan draft, which we have talked about a couple times. This has been recently adopted as a research group item So it's the version 0 now again. And what has been updated since the last version of this document is basically the CCNX stateless compression schemes that hadn't been defined yet. We only had defined NDN. And then, there's a renaming. Then we use ICN LowPan as a name to make it more inclusive for the different ICN dialects, and then security considerations were added. Just a brief recap, what is the objective of this draft? First of all, make ICN LowPan compliant, so define a convergent layer for low power lossy networks, in particular 802.15.4. Adapt this to the link constraints of this low power lossy network, and then define a couple of compression schemes, which are first of all the stateless compression for the TLVs, and second stateful compression, and I come to this in a second. Stateless compression is basically about more efficient encoding and the omission of redundant information wherever possible. And that means, first of all, we try to get the TLVs to smaller encodings. For instance, a Boolean bit vector can be reduced to a bit, and we also try to remove a lot of fields from the header wherever possible if they are not needed. For instance, length. If you're in a more or less confined length scheme, then you can adjust this to fixed length, and you don't need to carry this. Also remove redundant header fields. And there's an overview of the two. Is there a pointer here? Yeah. Anyway, of the two flavors, NDN and CCNX. So what you see, what is gray here, is the stuff that is basically attacked or reduced by the stateless compression. What we do is we use the 6 LowPan dispatch fields, which are needed anyway, because we want to make this LowPan compliant, and we encode bits, and that's on the lower line here. We encode bits about the presence of compressed fields according to the protocol. So what we see is NDN is a bit leaner. CCNX has many more options, so that means we have a longer dispatch field here. So just giving you an idea how this looks. So in NDN, we have this long type length value vector, and that can be reduced for the simple example that you have in the name ACM Boston. Oh, yeah, as you see there, then you see that we can reduce this to a shorter encoding here, and that is basically cutting out 18 bytes in this case. For the interest, and for the CCNX interest in the same case, it's even cutting out even more. But the original encoding had been longer. Stateful compression, to recap, there are two approaches. One is similar to the 6 LowPan approach, to put a context-specific state like prefixes or other stuff in common knowledge that is identified by context identifiers, so you don't need to carry it in the packets because it will be redundantly communicated. For instance, common prefixes, common suffixes, common options. And the second approach, that's unique to an ICN approach, is to replace the names if you send an interest, you send a name, and if you reply to this, actually the name is replied again, and you elide this name by generating short local IDs, so making it sort of a stateful hop by hop compression. This has a much stronger impact here. So if you look at the the example of the interest. If you compress this only using the common prefix out, then you're in the compression in this example by about 40%. In the data case where you omit the full name, then we are really down to something that is very small, which is important. Just recap, these link layers have very short NTU sizes, and it's a real advantage if we can put packets, or can construct packets that fit into these small link sizes of 127 bytes or so. So this was more or less to give the overview, and what we are now at is we have a draft that has a sort of a shape, and we want to stimulate a couple of discussions. First of all, the NDN CCNX folks. The question is this actually the other compressions as you like that? Does it meet the perspective of the groups? Also a question that some type and length restrictions in the compression, so names can be only a certain number of bytes, name components and so on. Question is this okay? Just to recap, we can always send uncompressed interests in data, so it doesn't mean that we're doing harm to the network, but if we compress, then we have some restrictions, and the question is, are they feasible? And do they actually match the common use cases? Are they actually the useful things to do? And another call to the community is on the implementers. We are working on implementing stuff, and we recently started a collaboration with the NDN OT team in UCLA. Actually, the NDN OT team was recently formed, and the question is, are we ready to implement this together? And are they willing to adopt this in code? I mean, making this code. Yeah, and to all, of course, are we in line with key use cases, or did we miss anything that is really relevant here? So please speak up on this. And our next steps will be continue implementations, get more code running, get more experiments, get more real experiences. Get an implementation for the CCNX, which is for us is just pretty new. And the question is, do we have any other? We only use CCN Lite, so are there any other people willing to work on implementations for CCNX? And regarding the document, I mean, we are planning to have a major editorial improvement just to make this document more readable, make it better, and that should be soon. That should probably be released way before the next IETF. And then we are, of course, asking for feedback to get this in a consensual state with the research group. Yeah, thanks. That was it.
Okay, great. Thanks. Are there any immediate answers to Thomas's questions? So, what could we say? So, when you do like one or two revisions, maybe get this done before Montreal until summer IETF next year?
That will be an option. It depends a little bit what the feedback is. I mean, if you have very, very controversial feedback, then we have to deal with it. If we converge quickly, then yes.
Yes. Okay. Yeah, sounds very good. Thanks. So just to put this into perspective, this is a really interesting piece of work because it enables us to, run the semantics of ICN without translation with a, say, convergence layer that is specifically adapting to the needs of constrained networks. And it's a very elegant way to basically have end-to-end ICN communication on the semantic level. And maybe that's actually something that you guys want to look into for your Bluetooth work. Great, thanks. Thanks a lot, everyone, for being so good on the time. So that gives me actually a chance to do a little exam with you now. So I hope you paid attention. for the German speakers, Hefte raus, Klassenarbeit. So in the beginning, I kind of tried to give you this overview about the technical activities here in Icnrg. And so if you're a networking person, you will surely see that there's some essential piece missing for a comprehensive communication framework that is supposed to do something useful. Anybody? So we have a packet forwarding service. We have technology on management. We're thinking about apps, mobility. What is still needed to prevent the collapse of the ICN internet? Guys.
Come on, routing and congestion control.
Right, so routing and congestion control. So it's not like there's no work on congestion control. There's been really good work. It's just hasn't been brought to Icnrg. So so in case you are looking for a way to make a dent in Icnrg, you could consider either one of those two topics. All right, thanks. That was just a quick reminder I wanted to communicate.
By the way, both of those are careers, not projects.
Okay, great. That brings me to the end. So yeah, we are planning the upcoming meetings. So probably we'll have the same setup in Prague. Depends, of course, a bit on what people bring to us. In previous year, not this year, but so sometimes earlier, we sometimes did an interim in January. So we haven't prepared anything yet. But if people want to do something, host something, please talk to us. That's a quick interim in Tokyo. Not sure whether we can align with that, but yeah, let us know.
The default state is that the next time we meet will be in Prague.
Yes.
So if someone wants to meet sooner than that, we'll work with you to arrange it and make it happen.
Right. Okay. Thanks again for the good presentations and thanks for coming.
You better fix fix what? Oh,
probably.
Well, it forced me to do just a simple update rather than recapitulate.
Okay,
Design
I
traces.
schedule.
Okay.
That was good.
You will fix it?
I thought someone looked at you.
Yeah, that's me. I just got here last night.
Yeah.